So we just finished up with the calculator and learning how to put in our data and create the line of best fit. I'd like you to be on page 287. We're going to talk about that value R that some of you see when you do that linear regression. This is called the correlation coefficient. And on page 287 in the middle, we can see several scatter plots. The first one looks similar to this. Second one similar to this. Third one has no correlation. I guess we better draw that. Points are all over the place. We're going to sneak the fourth and fifth one in here. And so we see these different scenarios. In the first one, we'll label it number 1, we see a definite negative trend in the data, and we see the data very tightly formed about a line that we could say was that line of best fit. Now this correlation factor tells us a lot with the calculator. The closer it is to 1 or to -1, the more closely the correlation. The closer it is to 0, the less or the looser the correlation. So if we look at example 1, we see a negative correlation first of all, and we also see it very tightly clustered. So we would expect our R value when we did our linear regression to be close to -1. The next one, they say we have negative correlation, but that data is very, very loosely fit about that line, and the book says about a -0.6. So it's getting closer and closer to 0. In the third one, we can see that there's absolutely no correlation, and we would expect that R value to be very close to 0. Going the other direction, in comparison, we see somewhat of a correlation, and we do see a positive trend. So we would expect that R value, should have been writing those in, to be roughly or close to 1/2. A loose correlation, a weak correlation, but not as weak as 0. And we see that it's positive, of course, because this line is increasing from left to right. And finally, the example, the data closely clustered around a positive increasing correlation of data. We would expect to see an R value of something close to 0.995, 96, 97, somewhere in there. I'd like you to look at example 3 on page 287. It says the table shows a relationship between a city's population and the average time the city's citizens spend commuting to work each day. If you turn to the top of 288, you can see that they've calculated that linear regression for you. I'm going to put a new sheet in here. Linear regression. In the calculator screen, we see A, 0.001. We see B to be about 23.8. And then we see our R value of 0.7. We see the correlation factor to be positive and to be fairly close to 1. So we would expect data that was not extremely tightly bundled around the line of best fit. And that line being, let's not fail to mention that, our line that the calculator just came up with is y equals 0.001 x plus 23.8. So in that set of data, our y-intercept being close to 24, our two sets of data, or things that we were comparing, were population and average commute time. And so we can see that function describing that data rather clearly, positive trend, and somewhat strong correlation. So it's time for this lesson's quiz. I'd like you to do this after you have completed the homework assignment, which is on PowerSchool. So in the first part of this quiz it says, this table shows time spent on homework and the number of incorrect quiz answers for several students. So kids who spent 2 hours on homework a week got, on average, 8 incorrect answers. As time spent on homework increases, we can see a relative trend. In the first case, it's not so true, but we do have a scatter plot, so we have 9 incorrect answers for that. But as 4 doubles to 8, incorrect answers goes down to 1, and it goes back up to 10. We have roughly 4. So we want to do 2 things. 2 lines of fit are negative x plus 11 and negative 1/2 x plus 8. I need you to go back through example 1 and find the sum of the squares of the residuals for each of these lines. I need you to graph the scatter plot, draw the line of best fit, and give the squares of residuals and figure out which of these lines is a better fit. After completing that, part 2 says, find an equation for a line of best fit. Interpret the meaning of the slope and y-intercept. So this is something we could do with our calculator and our linear regression. It says use the equation to predict the number of incorrect answers for 5 hours of study. This is your quiz, part 2. And in part 3, it says, how well does the line of best fit represent the data? And explain. So good luck on this. Lesson 4.8 is in PowerSchool. I can write those right here. However, we are doing 7 through 20. Make that, if you're watching the video, you get a bonus. It's 7 through 19, and we're just going to do the odds. Lucky you if you're watching.